Hello, Math Wizards! Welcome to a lesson episode of Just Math PH. So for today's lesson, our topic is all about quadratic inequality, where you will be able to solve quadratic inequalities using solution to quadratic equation and number line. So as a review, if equation, the word equation makes use of the symbol equals. Inequality makes use of the symbols less than, greater than, less than or equal, greater than or equal. And if the left side of these symbols are quadratic, we call these inequalities as quadratic inequalities. Now, let's study more on the symbols of quadratic inequalities. So we have here the symbol less than, that is facing to the left. Remember the symbol for less than, it faces to the left, while the symbol for more than faces to the right. You can remember it as more than to be going to the right because it goes to the positive value, while less than is going to the left because it goes to a more lesser and lesser values, smaller and smaller values, which is pointing to the left. While greater than or equal, which is the symbol facing to the right, but there's an bar below because of the word equal to. So greater than or equal to, which can also be translated as at least. And less than or equal to faces to the left with a bar below, and it can also be translated as at most. So example for less than, let's say less than 3. So these are the numbers that moves to the left of 3, but 3 is not included. So it could be 2.5, 2.25, 2, 0, -1, and so on. But 3 here is not included. It's not included. Here for more than, let's say greater than 5. So these are the numbers that moves to the right of 5, but 5 is again not included. It could be 5.5, 6, 7, 8, 9, 10, and so on. But if we have the greater than or equal, let's say 5, greater than or equal to 5. So these are the numbers that move to the right of 5, but since there's equal to 5, meaning 5 here is included. It's included. How about less than or equal to, let's say less than or equal to 3. Less than or equal to 3. So these are the numbers that moves to the left of 3, but since there's an equal 3, meaning 3 is included in that set. Included. So if there's a bar below or there's an equal to, then the numbers are included in the set of solutions. So if quadratic equation has at most two roots, just at most two roots, meaning it could have no real roots or one real root or two real roots, the quadratic inequality has infinite solutions or roots. It has infinite solutions. That's why we will write their solution in a solution set. But in solving quadratic inequalities, we will make use of the concept of quadratic equation. Quadratic inequalities can also be represented in a number line. So since we will be graphing quadratic inequalities on number line, we have to follow the following legend. So for less than, it moves to the left, and we will make use of the unshaded circle. And for the greater than, it moves to the right, and we will also use at the same time the unshaded circle, meaning the number after this symbol is not included. That's why it's unshaded. Then for the less than or equal to, it moves to the left, and this time we will make use of the shaded circle, meaning the number um, after this symbol or pointing by this circle is included. And for the greater than or equal to, it moves to the right and it is shaded circle. Let's have an example. Graph the inequality x less than 3. So let's make a number line. So since it's a line, do not forget the arrows. So we can have here our 0. Then we have 1, 2, 3, 4, 5, and so on. Then we have on the left side negative numbers and so on. So to graph this one, the symbol here is less than. So remember, in the less than, it moves to the left, and we will use the unshaded circle. So we will make use of the unshaded circle for 3. So you can do it above 3. Then we will move to the left. So make movement to the left. Do not forget the arrow, meaning the numbers included in the set are the numbers pointing to the left. So here, since 3, above 3, there's an unshaded circle. Therefore, 3 is not included in our solution set. Second example, graph x greater than negative 1. So for the greater than symbol, we move to the right and we will make again the unshaded circle above negative 1. So graphing it. So negative 1 is here. So let's put unshaded circle above negative 1. And then we will move to the right. So we will make array moving to the right. Okay, so this will be our graph for x greater than negative 1. It tells us that the solution set of this inequality are the numbers greater than negative 1. Here, notice these are the numbers greater than negative 1. We have 0, 1, 2, 3, 4, 5. Take note, there are also decimals in between these numbers. So 1.5 is also a solution, 2.5 is also a solution, and so on. So because of the arrow, it tells us that the solution for this are infinite. However, negative 1 here is not included. So only the numbers to the right of negative 1, but negative 1 is not included. 3, graph x less than or equal to 2. So we make use of the symbol less than or equal. So from our legend, it moves to the left, and this time we will make use of the shaded circle. So let's put the shaded circle above positive 2. Now, since it's shaded, meaning positive 2 is included in our solution set. So less than or equal to, so pointing to the left, we will move to the left. So the solution set for x less than or equal to 2 are the numbers on the left of 2, positive 2, and 2 is included. So for number 4, we have here x greater than or equal to negative 4. So from our legend, it moves to the right, and we make use of the shaded circle. So let's make a shaded circle above negative 4. Now, since our inequality is moving to the right, so we will make a ray moving to the right. It means that the solution set are the numbers to the right of negative 4, and negative 4 is included. So here are examples of quadratic inequalities. X squared minus 2x minus 24 greater than 0, x squared minus 7x plus 6 greater than or equal to 0, and x squared minus 4x minus 5 less than 0, x squared minus 9 less than or equal to 0 are examples of quadratic inequalities. Remember that we can only solve quadratic inequalities if they are written in the standard form. Now, to solve these inequalities, we follow two cases. So this is for the cases for greater than, and we have case 1, case 2, and the solution set. For greater than or equal to, these are our cases and the solution set. For less than, these are our cases as well as the solution set, and at the same time with less than or equal to. Now you will understand these cases eventually if we will have an example, because we will be applying these cases to our example. So let's solve this quadratic inequality, x squared minus 2x minus 24 greater than 0. So since these quadratic inequalities will be solved using the concept of quadratic equation, we have to write this one into quadratic equation. So x squared minus 2x minus 24 is equal to 0. So this is factorable, so we will apply Vedic in finding the roots. Our A is 1, our B is negative 2, and our C is negative 24. So multiplying A and C, we have negative 24. Then we will find two numbers. If we will multiply these numbers, it will be negative 24, but if we add them, it will be negative 2. So what do you think are the numbers? So we have here negative 6 and positive 4. Since negative 6 times 4 is negative 24, but negative 6 plus 4, that's negative 2. And then we divide it by our A, which is 1. Thus we have negative 6 and positive 4. Do not forget to flip these numbers or change their signs. So 6 and negative 4 are our roots. So we have to assign the roots as R1 and R2. So R1 would be our smaller root. So the smaller root here is negative 4. So let's write negative 4. So this one is the smaller. And for our R2, we will choose the bigger one. So this is the bigger root. So this one is our R1, the negative 4, which is the smaller root, and R2, which is 6, the bigger root. So let's erase this part. Okay. So our roots using Vedic are negative 4 and positive 6. Next step is to apply the cases for the inequality greater than. So we will follow these cases. For case 1, we have it here, and for case 2, we have it here. So let's write first the case 1. So for case 1, we have x greater than r1 and x greater than r2. For case 2, we have x less than r1 and x less than r2. So what we will do, we will graph these two inequalities here on one number line, and then we will determine their intersection. So that will be the solution for that case. So let's rewrite this one. So x greater than r1, which is -4, and x greater than 6. For case 2, we have x less than -4 and x less than +6. So let's graph case 1. So we have here, let's put 0, and then let's say this is -4, and we have here +6. Also on this side, we have 0, then -4, and +6. So x greater than -4. So this one is both, these two are both unshaded, and that would be, let's put unshaded circle above -4, and it moves to the right side. And for x greater than 6, let's have an unshaded circle above 6, and it moves to the right. So notice that on the graph, it intersects on this portion, right? Up to that side, because our x greater than 4 extends, right? It extends. So eventually, from here, it will intersect. It will join on this part. So the solution set for that part would be, so our SS1, or solution set 1, would be the part where they intersected or they joined. It starts from here, which is x greater than 6. Now let's move to case 2. Now let's graph x less than -4. So it moves to the left, unshaded. And for x less than 6, it also moves to the left, unshaded. Okay, right? Now notice on this portion, up to the left side, from this portion to the left side, these two lines will eventually join. They will intersect. So that will be our SS2. So our SS2 is the part where they intersected. which starts from here to the left side. So x less than negative 4. Now, we have the two solution sets SS1, x greater than 6, and solution set 2, x less than negative 4. Therefore, if we graph these two solution sets on one number line, graphing that on one number line, this is, let's say this is our 0, and we have here our negative 4, and we have our 6 here. So graphing that, it would look like this, right? Solution set 1 would be the graph here. It will be the graph here. And for solution set 2, it is x less than negative 4, which is this graph. So we will write the solution set final joining the two sets. So our solution set final for the two cases that we have would be the x, let's start with the left side, x less than negative 4. We will start on this side. Or, we will use the word or x greater than 6. So this is our solution set for the quadratic inequality x squared minus 2x minus 24 greater than 0, and this is the graph for that solution set. Number 2, solve x squared minus 7x plus 6 greater than or equal to 0. So first, let's rewrite it into the quadratic equation. X squared minus 7x plus 6 equals 0. Using Vedic, we can solve the roots for this equation. So the roots are 1 and 6 using Vedic. So since 1 is smaller, this will be our R1 and 6 will be our R2. So R1 is 1 and our R2 is positive 6. So take note of the inequality symbol. It is greater than or equal to. We will make use of these cases here. So for case 1, we have it here, x greater than or equal to R1, which is positive 1, and x greater than or equal to R2, which is positive 6. For case 2, this is our case 1. For case 2, we have x less than or equal to R1, which is 1, and x less than or equal to R2, which is positive 6. So this time we will graph the cases. Then let's determine where did they intersect. So let's make first a number line. So we have 0. Let's say this is our 0. Let's say this is our 0. Then we have positive 1. Let's say this is our positive 6. So x greater than or equal to 1. So this one has an equal to, so we will use of shaded. So for shaded, circle. Let's put it above 1. Now it moves to the right. Then for 6, x greater than or equal to 6. So that is still shaded and it moves to the right again. Okay. So where did they intersect? So on this portion, they had intersected and it continues to the right side. So the intersection is the part where there is x greater than or equal to 6. And on this side, let's graph case 2. So let's say this is our 0. Then this is our 6. So let's say this is 1. Now x less than or equal to 1. So this is shaded. Above 1, there's shaded circle and it moves to the left. And x less than or equal to 6. Above 6, we will put shaded and it will move to the left. So where did they intersect? So on this portion, they intersected and it continues to the left side. So their intersection is the part where we have x is less than or equal to 1. So let's graph the two intersections on one number line. So graphing them on one number line, it would be this. Okay. So we can put 0 here. 1, 2, 3, 4, 5, 6. So it's up to you if you will write all the numbers here. It's up to you. So let's graph this one. So x greater than 6, shaded, and it's moving to the right. While x less than or equal to 1, shaded above 1, and it moves to the left. Okay? So, this graph here represents x less than or equal to 1. And this graph here represents x greater than or equal to 6. Therefore, our solution set are the set of numbers such that x is less than or equal to 1 or x is greater than or equal to 6. So we have to write our solution set reading from left to right. And this is our graph for the quadratic inequality x squared minus 7x plus 6 greater than or equal to 0. This is the graph and this is our solution set final. Number 3, solve the inequality x squared minus 4x minus 5 less than 0. So first, let's rewrite it into the quadratic equation. That is x squared minus 4x minus 5 equals 0. Where the roots using Vedic, we have positive 5 and negative 1. Now, R1 should be the smaller one, so this will be our R1. This is R1. And R2 is the bigger one, so this will be our R2. So negative 1 is R1 and R2 is positive 5. Next, let's notice the cases. or determine the cases for this inequality. We have here less than 0, so we will make use of these cases here, case 1, and that will be our case 2. So let's write the case 1. So for case 1, we have x less than r1, which is negative 1, and x greater than r2, which is positive 5. Take note, it is greater than positive 5. And for case 2, x greater than r1, which is negative 1, and x less than r2, which is positive 5. So let's graph these cases on a number line. So let's graph x less than negative 1. So less than, so we will put unshaded circle above negative 1, and it moves to the left because of the less than. And for x greater than 5, unshaded circle above positive 5, and it moves to the right. Now, do we have an intersection? Obviously not. So this is what we call an empty set. It's empty, meaning there is no intersection on this part. So case 1 is an empty set. Now how about case 2? So we have x greater than negative 1. So unshaded above negative 1, and it moves to the right side. And x less than 5, unshaded circle above 5, and it moves to the left. So where do they intersect? So notice that they intersect only on this part, between negative 1 and positive 5. So it's between negative 1 and positive 5. So our intersection would be between negative 1 and 5. Why between? Because negative 1 is not included and 5 also is not included because they both have unshaded circles. So it's between. So only the numbers that we have here, only the numbers between negative 1 and positive 5 would be the solution set of this inequality. So let's graph it on one number line. So graph the solutions on one number line. So this is negative 1. On this would be our positive 5. So 0, 1, 2, 3, 4, 5. Let's say this is 5. So the solution set graph would be this portion, right? So that is our graph. So how do we write the solution set for that? That would be negative 1 less than x less than 5. It means that the solutions for this inequality are only the numbers between negative 1 and positive 5. So this is our solution set. And this is our graph. For example, x squared minus 9 less than or equal to 0. Let's rewrite it again in the quadratic equation. That is x squared minus 9 equals 0, where the roots are negative 3 and positive 3. So we can solve this using Vedic or extracting square root, right? Extracting, or we could also use Vedic. So our R1 is the smaller one, which is negative 3, and R2 is positive 3. So this is negative 3 and this is positive 3. Now notice that our inequality is less than or equal to. So we will use these cases that we have here. And this will be our solution set, combination of the two cases. So let's write our case 1. So that is x less than or equal to r1, which is negative 3, and x greater than or equal to r2, which is positive 3. For case 2, that is x greater than or equal to negative 3, and x is less than or equal to positive 3. Now, graphing these cases on a number line. So let's graph them. So let's say this is our negative 3, and this is our positive 3. This is our negative 3, and this is our positive 3. So let's graph x less than or equal to negative 3. So put shaded circle since it's less than or equal to, and it moves to the left. And for x greater than or equal to 3, shaded circle, and it moves to the right. Now, do we have an intersection? No, we don't have an intersection. Therefore, this is an empty set. Now, look at case 2, x greater than or equal to negative 3. So, shaded circle above negative 3, and it moves to the right. And another one, shaded circle. Okay. Shaded circle above positive 3, and it moves to the left. So where is our intersection? So on this part, right? The two rays intersect on this part. Now, since both are shaded, our intersection starts from negative 3 to positive 3, right? So the solution set would be starting from negative 3 up to the numbers here to positive 3. So let's graph that one on number line, on one number line. So this is our negative 3 and our positive 3. So it will look like that, right? So this is our graph for x squared minus 9 less than or equal to 0. So how do we write our solution set? So our solution set would be negative 3. So start from negative 3, less than or equal. So we follow less than or equal. So followed our solution set here. R1 less than or equal to x less than or equal to R2. So our solution set is negative 3 less than or equal to x less than or equal to positive 3. It means that the solutions are or starts from negative 3 up to the numbers to positive 3. So this is our solution set, and this is our graph.